Alrighty hosses, welcome back, and in this video I want to talk to you about routing tables. Now I want to explain this because if you think about it, whenever you connect to some website on the internet, you just aren't directly connected to that website. In order for your data to get there, it has to pass through a bunch of routers. So how do these routers know which path to take? I mean, if you ever looked at the router in your house, it has a bunch of Ethernet cables plugged into it, and it has a bunch of different options. So how does it choose what road to send your data down, let's say whenever you're connecting to YouTube? Well, it uses something called a routing table, and if you're on Linux and you type the word route, then these are all the routes that you can take. And this is just the one for my own computer, but the concept is the same whether it's on your router. I mean, they all work the same. So I'll just explain real quick what these columns mean before I go over any examples and details. This destination, just remember that it's going to look at the final destination, the end path or the end IP address of whatever server you're trying to connect to. This gateway is just the IP address of your gateway or your router. And if you don't understand why people refer to routers as gateway sometimes, is because your router is a gateway to another network. That's all routers are. They just connect one network to another. Now, all of these computers aren't directly connected to one another. They have to pass through this door to another network. So, for example, all of the devices in my house, my tablet, my phone, my computer right now, they all have to pass through the router in order to get to the internet. So it's just a door to another network, in my case, the internet. Now, this mask is, of course, a subnet mask. We know all about that. There's a bunch of different flags. Whenever you see a U, probably the two most common flags are U and G. U means that this route is up. So you can use this route. It's up and running. That's fine. G means gateway. So this route right here, it uses a gateway, and that means that whenever we send data down this route, it's going out the door to another network. Now, the other really important one is this iFace, which is interface. And this is just if you have a bunch of different NICs on your computer. I have this one, which is my Ethernet one, and this one is my wireless one. So I'm sure you guys know all about that already. So now that we kind of got the terminology taken care of, let's look at an example of when we would actually use this. So right now, let's say that I want to connect to thenewboston.com and the IP address is like 54.123.2.2, whatever. So I'm going to form a packet and I'm going to put this as the destination. That's where I'm going to try to send it. So now it's going to say, okay, let me check it out my routing table and let me decide what path I'm supposed to go down. So the first rule that it always reads is this default one. And this just means I'm going to look for every other rule to see if this destination matches, and if it doesn't, then I'm just going to use the default rule. So every routing table, it always has at least a default rule. What do you want to do by default when no other rules match? So then it's going to keep going and it's going to say, okay, so is this IP address in this network? Well, no, this is just my home network. So anything starting with this is going to fall under that category, which clearly isn't this. Well, what about this one? Well, no, it's kind of the same set of rules. All right, so I guess I'm just going to follow this default route right here. So whenever I'm trying to connect to this IP address, which is my website, then I have to pass through this gateway, this door, and again, this is my router. So once it gets to my router, it's going to follow its own set of rules, and it's eventually going to go out to the internet, and every single router is going to do this, and then it's going to come back, and get to me. But what if I just want to, print something on a printer that's right next to me? Well, the IP address of the printer is going to be something like 192.168.0.15, whatever. Well, then it's going to say, okay, you want to connect to your printer? Let me look at my routing table to figure out how to get there. Alright, so this is the default rule, so if I don't hit any, then I'm just going to use this one. Alright, so what about this rule? Oh, yep, actually these two rules, these ones actually match. So let me see where I'm supposed to get it. Well, I don't need to use any gateway, and this kind of makes sense because we're not going out any doors to any other network, so this is why this is actually start out. And whenever you hit a rule and this is start out, then it pretty much always means that it's on the same network as you. So whenever there's no gateway, it must mean that this device is on the same network as my own computer. So we can verify that because, yep, according to the subnet mask, any device that falls in this network, I mean, it's on the same one. And what interfaces am I supposed to send it out? Well, just ETH0 and WLAN 0, which are my two NICs. And another way that we can see that, okay, this doesn't need to pass through a gateway, it's pretty much on the same network, is that there's no G flag for this. So the route is up, I can connect, no problem, but I don't need to use a gateway to get there. Now the last thing I want to explain before I let you guys go is what happens whenever your final IP address, such as like 192.168.0.15 or whatever, what if it matches more than one rule? What one does it follow? Because if you think about it, I mean, all of these rules, so if I'm trying to connect to this device, then it matches this rule, but it matches these ones too. So, I mean, how does it know what path to take? Well, whenever it matches multiple rules, then it chooses the one with the longest subnet mask. In other words, this subnet mask, in CIDR notation, this would be /0. Now, this subnet mask right here, remember CIDR notation, this would be /24. So it looks at the one with a longer subnet mask, and since these both have /24, then it's going to use these set of rules right there. So I know it's kind of overwhelming at first, but that is how each router in each device can look at a packet, look at where it's going, and decide which path to send that data down. And that's how all of these routers can communicate efficiently, quickly, and there you go. So in the upcoming tutorials, we're eventually going to get into how to set these paths manually, and I'm going to be showing you guys something really cool, and that is how to turn your own personal computer into a router. And we're going to look at why this is actually what hackers do sometimes. And well, I'm kind of getting ahead of myself, but it's going to be awesome, so I'll see you guys then.